Sanjeev, and this is my project lip reading using LipNet model. Basically, this is the implementation of LipNet model. So starting off, we start off with loading the data and checkpoints. And coming to data, we have video files where the speaker speaks a sentence,
Bin Blue F2 now.
and we have the respective alignments for that, which is yeah, bin blue at F2 now. So basically, these alignments also have timestamps with them. That's how they created this data set. So this is the original models I trained on. This model takes very long to run, so I didn't run it. I didn't run it in this notebook. I ran it in another notebook, but that was lost. But I'll make sure to run it by the time after the video is done. Coming to this, it's basically loading the same model from the checkpoints. Everything is there. That's there here is also there in this. Coming, we basically improved everything we need. We we define the vocabulary, and we have a custom load data function which takes the loads of video and alignments. And for video, we crop the video and normalize the video, and for alignments, we take the text that is there in the alignments. And load data function basically gives out the normalized frames. um, Normalized frames looks like this after video processing. So it gives out normalized frames and align and the process alignment, which is the text we want. That's in tensors. So uh, so this is a data pipeline which basically takes the data, shuffles the data, and splits it into train and test. This mappable function maps the video path with the alignment path. Um, Custom callback. So this custom callback runs after every epoch. So it updates the learning rate and logs the loss. We are using CTC loss, and after every uh, epoch, we uh, we try out the model with sample text and the prediction for that sample video. So connectionist temporal classification loss is the loss that they used in the paper. I saw some implementations on the internet and included in the model. Coming to the model, it has three convolution layers and two bidirectional LSTM layers. So they had GRUs in the original paper. We tried with LSTM and it performed better, so we stick with that. And we had to experiment with leaky Relu and the alpha for it. It performed better than the normal Relu, and I'm guessing it's because it does well with vanishing gradients. Um, Kernel initializer, we went with low dot uniform. We also tried orthogonal. This performed better, so we went with it. Which like after the last layer has softmax activation, as you can see. So this is the code to load the models, and obviously compile the model using Adam optimizer. And this is the code to save the checkpoints. So uh, since I only ran this for one epoch to make things clean, so after the last epoch we can see uh, well, not this is 56, but we could train it more but here we got um, good results. So I didn't plan to go more. Set the original sentence was set white at I2 place, and the prediction was set white at I2 place, and the same for here. So the loss is almost zero here. This for training set. Coming to validation set, set white. So the real text and prediction text, there is a difference. I think it missed a space or two or a character or two, and we calculate the error by using CTC, and also we evaluate using WER, which is word error rate. If we go here, this is the code that calculates word error rate that I took from the internet. So yeah, that's on validation set. Now, if we want to see it on a particular video file, let's say for this one, pwby1a, we send it to our load data function, which returns us processed frames and processed text, like, and the respective alignment, and these are the functions basically to show the frames of processed and unprocessed videos. So this is the frames from that video. We take 75 frames, and this is the processed frames from that video. As you can see, like it is cropped and normalized. So the real sentence spoken in that video was place white by y1 again. uh, y1. Okay, this is the alignment, and this is the video for the respective audio file.
Place white by Y1 again.
Yeah, sorry, respective text file, and we pass it to the model. Sample one is what we uh, the variable which loads the data. We pass it to the model and predict it. It says place white y1 again. So it's not bad. It's definitely understandable. So we calculated the word error. Sorry, I calculated the word error for that, and it's 0.33, which is not bad at all. So I also uh, tested on my own video. So I had to modify the load data function for that, because my own video, like the dimensions were different, and also like where the mouth is respect to uh, data set is different. So I loaded my sample and did the same. This is my video, my 75 frames, and this is my mouth normalized, my 75 frames. So the real text I said was bin blue 76. It should be okay. The real text I said was bin blue 76, and What it predicted was bin Ari well, at least it got the first word correct. So it's, I mean, since we didn't train it on the on my data set, and since we didn't have the conditions that the grid data set had, it is understandable that the model is not doing that good on my video. And yeah, um, that is that is my that is the end of my results. Thank you.